All right, let's get going on the homework. 9.1. All right, we're doing numbers 61 through 65. All right, so you should be using these videos as a way to check your answers. Make sure you're doing them right. Okay, and here we go. Number 61, the function f inverse of x is the inverse function of f of x equals 3 times the square root of x plus 4. What is the range of f inverse of x? Okay. Well, let's come up with the domain and range of f of x, and then all we have to do is Freaky Friday it, and we can find the range of its inverse. So let's just do the DNR for f of x. So we know that this is a square root function, right? So that plus 4 means it was shifted to the left 4 units. So, and then that 3 out front means that that is a vertical stretch. Okay. So, if I were to think of it on the graph, 1, 2, 3, 4, it's like that. Okay. So, I know that the domain, the lowest x value that it's using is a -4. So, x has to be greater than or equal to -4. The range, the lowest y value it's using is 0, but it goes from 0 to infinity, so y has to be greater than or equal to 0. Okay, so when we Freaky Friday the domain and range and find the domain and range of the inverse, all we have to do is switch them. So the range is the same as the domain, but instead of x, we do y, greater than or equal to -4. So this is the one we needed to find. So y has to be greater than or equal to -4, so it is C. I had to change it. There was a typo. It said x greater than or equal to 0, x greater than or equal to -4, x greater than or equal to 4. So I changed them all to y's. With my tablet pen, I wrote on my PDF and I saved it that way. I fixed it. It's all good. All right, number 62, it says, which represents the domain x such that x is a real number and x has to be less than or equal to -1 in interval notation. So this little piece right here, it's kind of extra. They're saying that x is a real number, so they're being very specific on the type of number it is. But x is anything less than or equal to -1. So that means it's going from -1 on the right to -infinity on the left. So basically -infinity to -1. But because of that or equal to, there's going to be a square bracket on the -1. This one doesn't have the square bracket on -1. Neither does this one. Can we have a square bracket on infinity? Nope, we're never going to equal infinity, so it's not A. So it's got to be D, -infinity to -1. The square bracket is only on the -1 because we can equal the -1. All right, number 63, it says use the function f of x for items 63 through 65. 63, what is the inverse? So change f of x to y. And then Freaky Friday. So switch the x and y's places. And now we've got to solve for y. So we need to get the y out of the radical. It's a square root, and the only way to undo a square root is to square it. But whatever we do to one side, we must do to the other. So we're going to get x squared equals, poof, y plus 3 gets to come out. And then we just have to solve for y. So we have to subtract 3 from both sides. So we'll get y equals x squared minus 3. Let's put it back in function notation. So our final answer will be f inverse of x equals x squared minus 3. And there we go. Number 64. Let me zoom out a little bit. says, give the domain and range of f of x and f inverse of x. Write your answers using inequalities, set notation, and interval notation. Okay, so let's write the domain and range of each of those. Start with f of x, d and r. Okay, so f of x. It is basically the parent square root function shifted to the left 3 units. So if I drew a quick sketch, I know it looks like that. Okay, so the lowest x value it's using is a -3, but it's -3 and then the arrow goes to positive infinity. So as an inequality, it would be x greater than or equal to -3. In set notation, it would be x such that x is greater than or equal to -3. And then in interval notation, it would be from -3 to positive infinity. The range, well, the lowest y value that it would use would be 0. But it's above the x-axis, so it's 0 to positive infinity. So y has to be greater than or equal to 0. In set notation, that would be y such that y is greater than or equal to 0. And in interval notation, that would be from 0 to infinity. All right, so that is f of x, domain and range. Now let's come up with f inverse of x, domain and range. And all we got to do is Freaky Friday the domain and range of the original function. And that pretty much gives it to us. So then the domain of f inverse would be this. So instead of y, though, it's domain. We have to put x greater than or equal to 0. So in set notation, that would be x such that x is greater than or equal to 0. And then in interval notation, 0 to infinity. And then for the range, instead of x's, we got to put y. So y greater than or equal to -3. In set notation, y such that y is greater than or equal to -3. And then from -3 to infinity. I just love how there's just such a logical process. And once you know the patterns and once you know the domain and range of the original, all you have to do is Freaky Friday it and you have the domain and range of the inverse. Easy peasy. All right, number 65 says graph f of x and f inverse of x on the same set of axes. So now we're really going to graph it. So we have f of x equals the square root of x plus 3. And we know that this is the parent function shifted to the left 3 units. So the parent function always starts at 0, 0, go left 1, 2, 3. Okay. And there's no stretch or shrink, so I know that it's going to have an exact point up here. And I'm just going to fake the rest of it. And there is f of x. For g of x, f inverse of x, we know that its inverse is a parabola, but it's only going to be half a parabola because only half is showing here. Okay, and we just have to Freaky Friday it. So let's see. If I have these 2 points, that is the point -3, 0. Freaky Friday the point -3, 0, and you get 0, -3. And then the second point right here is -2, 1. Freaky Friday it, and you get 1, -2. And doesn't it look like? It's got to be a parabola, so we know it's half a parabola. Parabolas are either facing up or down, and then you have the diagonal that cuts it in half, the line y equals x. It's beautiful. And there we go.